All right, 8.3 present value. So present value, what is present value? Okay, present value is the value of an investment or loan on the date before the end of the term. Okay, so this is usually the initial amount. Okay, so initial amount slash principal. Okay, and then what happens is we have some future value, and this is the value of the investment or loan at the end of the term. Okay, whatever the term is, could be 2 years, could be 7 years, whatever it is, it's at the end. Okay, so here is the present value formula or the principal formula. Like you could think to yourself, what was the initial investment? If this investment or this loan cost this much money or accumulated to this much money, what was the initial? That's kind of like what we're thinking here, okay? So in this formula here, this is simply the formula that we were using yesterday for compound interest. It's just rearranged, okay? And I already rearranged it for you, so there's not going to be any issues with like the rearranging with just the math. So all of these variables are going to be the same thing as what they mean yesterday. Okay, the A is still the accumulated amount, which is the final amount, right? And so this would represent the principal and the accumulated interest. Okay, P is the present value. We've been calling it principal up until now. It's also called the present value. Okay, I is the interest rate as a decimal. And remember, we take that decimal and we divide it by the number of compounding periods. And N is the number of compounding periods. So this is just like the number of years, usually time, right? Time, and then times the number of compounding periods per year. Okay, and we already have this, so this is just a recall. If it's annually, it's 1 time a year, semi-annually, 2 times a year, quarterly, 4 times a year, and monthly, 12 times a year. Okay, so this is just for a quick reference. Okay, example 1. Oh, and I'm going to leave this at the top of the board. Petra wants to have enough money to buy a car that costs $5,000 in 2 years. Okay, so in 2 years, so then N, we're going to start with the 2. She wants to have $5,000. So that's going to be the end amount. That's what she wants in the future. Okay, now this says if she invests her money, so here's the thing, her money, we don't know how much money she's going to invest, but if she invests that money at 6%, okay, so remember 6 as a percentage, you just divide by 100. So we get 0.06. Compounded monthly, how much does she need to invest? Okay, so you're thinking automatically, how much do I need to invest today in order to have $5,000 in 2 years? Okay, so monthly. Monthly is 12. We're going to divide the interest rate by 12 and then multiply the years by 12. So she's actually getting paid out instead of 6%. She's going to get paid out 0.005, but instead of getting paid out twice, she's going to get paid out 24 times. So let's write the formula for the present value, right? That principal amount. So we're going to write P equals A 1 plus I to the exponent negative n. Okay, and be very careful. This is a negative this time. I don't know if we've seen that yet. So A is going to be 5,000. 1 plus I, our I is 0.05. 0.05. There we go. And then it's the exponent negative n. So it's going to be negative 24. Okay, if we were to add 1 plus 0.005, obviously it's simply 1.005. So in BEDMAS, let's do the exponent first. Okay, so let's put 1.005 to the exponent negative 24 into our calculators and see what we get. Okay, we get 0.887, let's go 2. So leave this number in your calculator. So mine's going to be like a little bit longer than that and not rounded. That's fine. And now we just multiply by 5,000. Okay, so I get 4,435.93. Okay, and what this actually means is, okay, therefore, in order to have $5,000 in 2 years, Petra must invest right now $4,435.93. Let's go like today, right? As in like now, like the future, or sorry, the present value. Example 2, Brittany borrowed some money, okay? So we don't know how much amount of money, so some money, so the principal amount, I don't know, okay? But at 12% per year. So remember that percentage sign means divide by 100. So our interest rate is going to start at 0.12. Okay, now compounded semi-annually. Let's come back to this. After 5 years, okay, so as soon as I see 5 years, we know that has to do with time. Okay, she paid $13,382.26 to pay off the loan. What sum of money did Brittany borrow? Okay, so see how it says after 5 years she paid this? That's like together. You have to be able to like read that and be like, okay, after 5 years, that means later. That means future value. Okay, so we want to divide the interest by 2 and multiply the time by 2. So 0.06 will be the interest rate, and it will be paid out 12 times. Okay, sorry, this is 10. 5 times 2 is 10. So the equation that we have is P equals A, 1 plus I to the negative n. So let's go ahead and sub A in. It's 13,382.26. Now, the 1 plus I, I'm going to skip a step. I'm going to do 1.06. Okay, so I'm just going to directly add it. Okay, and then to the negative 10. Okay, so in BEDMAS, let's calculate the exponent first. Okay, so we're just going to copy down the original or the end amount, okay, the future value. And then if we have 1.06 to the negative 10, we get 0.55, oops, I put a decimal there, 84. Let's just round. Okay, I am going to leave that in my calculator, so the end decimals might be just a little bit different, but I get 7,472.58. Okay, so what this means is that Brittany originally borrowed $7,472.58. Okay, if you think about borrowing $7,000 and then having to pay out $13,000, that's a lot of interest. Okay, you're thinking roughly $6,000 in interest. Okay, so just by borrowing that money at a really high interest rate, 12%, she's almost doubling what she needs to pay.